Hi guys, welcome to Calculus Crush. Today we're going to be using the definition of the derivative to find the derivative of the function y of x equals 1 minus 3x divided by 2 plus x. Now this question can be done quite a bit easier using the quotient rule because we have a function divided by another function. We're going to pretend we don't know the quotient rule and we're going to use the definition of the derivative. To begin, let's write the definition of the derivative. Y prime of x is the limit as h goes to 0, y of x plus h minus y of x, all divided by h. Now we need to substitute in x plus h for y of x. Every time we see an x, we just need to replace it with x plus h. So first we start by writing the limit as h goes to 0. And up top here we have 1 minus 3 times x plus h divided by 2 plus x plus h. So this quantity here is y of x plus h minus y of x, which is 1 minus 3x divided by 2 plus x. And that whole thing is divided by h. Next, rewrite the limit as h goes to 0 because we haven't taken the limit yet. And let's start. Well, actually, before we expand this, I want to write this on a common denominator. So we've got fractions, one fraction minus another fraction. In order to write them on the same denominator, we need to find a common denominator. And the common denominator is just each denominator multiplied by each other. So the common denominator is going to be 2 plus x plus h times 2 plus x. So I need to multiply this one by 2 plus x over 2 plus x. So I'll do that here. 2 plus x times 1 minus 3 x plus h. I'm going to use big brackets because I've got small brackets in here already. Minus 1 minus 3x times 2 plus x plus h. And this whole thing is divided by 2 plus x plus h times 2 plus x. And this whole thing is divided by h, so we can just write the h right here. Okay, let's start to expand these expressions now. The limit as h goes to 0. What we're going to find is we're going to expand this and we're going to be able to cancel out a lot of stuff. First we have 2 times 1, which is 2, minus 2 times 3x plus h, which is 6x plus h. And then we have plus x, and then minus 3x times x plus h, minus, I'm going to keep the brackets here, 1 times 2, 1 times x plus h, minus 3x times 2, minus 6x, minus 3x times x plus h. And this is all divided by h times 2 plus x plus h times 2 plus x. Okay, And we got to do probably one more expansion to get rid of all the bracket signs here so we can start canceling terms out. So we have 2 minus 6x minus 6h plus x minus 3x squared minus 3xh minus 2 minus x minus h plus 6x plus 3x squared plus 3xh. Wow, that's a lot of terms. And on the bottom, h times 2 plus x plus h times 2 plus x. Okay, now we should be able to start canceling some stuff out. All right, first of all, we've got a plus 2 and a minus 2. We've got a minus 6x and a plus 6x. We've got a minus 3x squared and a plus 3x squared, minus 3xh and a plus 3xh. We've got a plus x and a minus x, and all we're left over with is a minus 6h and a minus h. So that's minus 7h divided by h times 2 plus x plus h times 2 plus x. So most of these terms actually canceled out up here. Now the next step, we've got an h over h, so we can cancel that out. That's exactly why we did all this work here, so we could get rid of the h over h, which causes a 0 over 0 problem when we take the limit. So we've gotten rid of that 0 over 0 problem. So I'll write it out. Our last step before we take the limit, I'm going to write the bottom first. 2 plus x plus h times 2 plus x, and minus 7 is on top. Now if we actually take the limit, we just need to set all of the h's in this expression equal to 0. There's only one h at the bottom, so we set that equal to 0, and what we're left over with is 2 plus x times 2 plus x and a minus 7 on top. I'm going to go up here now. To write this correctly, it would be minus 7 over 2 plus x squared. So that is y prime of x. Alternatively, you can write it as y prime of x equals negative 7 times 2 plus x to the power of minus 2. It's the same thing. It's probably a little bit better to write it this way, but it's up to you. Thanks a lot for watching. If you have any questions, just leave them in the comment section. I'd be happy to answer them. Please subscribe. I'm going to be uploading lots of these videos with many, many different examples using all of the differentiation rules, not just the definition of the derivative.